Assalamualaikum and hi students. This is a lecture video for BMCG 1013 Differential Equations. The last topic for this subject is Partial Differential Equation, Chapter 5. So the learning outcomes that will be covered in this lecture video are to identify the order, linearity, homogeneity and classification of the partial differential equations, PDE. And then to understand the method of separation of variables, and the last one is to solve the initial boundary problem of PDE using separation of variable methods. In 5.2, we will try to learn what is method of separation of variables. So here, it is an effective method in solving several types of PDE. In 5.2, you will need to use your knowledge on solving Fourier series because it becomes a very important part when solving a PDE using this method. Okay, the three basic steps are, the first step is to separate the variables. Okay, a PDE is separable. It is separable if it can be rearranged in such a way a function of on the left hand side while a function of on the right hand side of equation. The solution of PDE is in the term of uxy equal to function x multiplied by function y, or we can write this as uxt equal to x multiplied by t. If you have uxt function, where x and y denote the function of x and y alone. Okay, you can split x and t, you can split x and y. Okay, to reduce a linear PDE in two variables of ODEs, okay, differentiate partial uxy with respect to x or y. So you note that del u over del x, so basically is equal to x prime y. So from here, you have uxy equal to x multiplied by 1. So if you find what is del u over del x, it is x prime y. Del u over del y is x y prime. Del square u over del x square is x double prime y. Del u square over del y square is equal to x y double prime. And lastly, if you have to find what is del square u over del x del y, it is x prime y prime. Okay, you need to use this substitution to solve for the first steps. So remember this. Next, divide the ODE, divide everything here, okay, with uxy. Divide x prime y divided by xy, each of them, okay, divided by xy will result a separation of variables x and y on both sides of the equation. We will see few examples in example 5.5 on how we can split, how we can separate the variables x and y. Okay, so the first example, you have del u over del x equal to del u over del y, and u is equal to uxy. Okay, so for A, we let uxy equal to products of x and y, variable y. Okay, so x prime y, del u over del x. Okay, so del u over del x is x prime y equal to del u over del y is x y prime. You substitute del u over del x with x prime y, del u over del y with x y prime. So you have this x from here, x prime y equal to x y prime. Then the second step is to divide everything with x y, left and right side. Okay, so you can cancel out this y, cancel out this x. So you left with x prime divided by x equal to y prime divided by y. Now you know this is separable. Because you don't have any y, on the left hand side, and you don't have any x on the right hand side, so it is sparable. Okay, look at B. You have del square u over del x square. Again, you let u xy written as x y y. So del square u over del x square is equal to x double prime y. Okay, plus del square u over del y del x. This is y prime x. Sorry, yes, x prime. Okay, plus with del square u over del y square. This is x y double prime. Okay, equal to 0. Then next, divide everything with xy. Xy, xy, and xy. So you can cancel this y. You cannot cancel this x or y. Cancel this x. Okay. So now you have x double prime divided by x. Plus x prime y prime divided by x y. Plus with y double prime divided by y equal to 0. Since there is no y here, so it is sparable. You don't have any x here, it is sparable. But for this term, you have both x and y. So you have to conclude that this is non-sparable. PDE. And if it is non-sparable, so you cannot use the method of separations of variable to solve this. Okay. C. Okay. You have to let u equal to x, y equal to x dot y. Okay. And then substitute x prime y prime plus x prime y equal to 0. Okay, try to do this. The answer for this third example is non-separable. Try to continue from here. Okay, once you know how to separate the variables, okay, so we can proceed with second step, which is solving the separated equations. Okay, since the variables x and y are independent of each other, the only way to get equality is to have both functions equal to a constant. Okay, then rewrite the separated equation as two ordinary differential equations. And the last one, there are three possible cases considered for parameter k in two differential equations above. So you can have these three cases. First case is if k is positive, so we let k equal to lambda square. And second case, if k is equal to 0, so k equal to 0. And the last one, if k is negative, so we have k equal to negative lambda square. Example 5.6, solve the PDE below using the separation of variable method. You have PDE for del square u over del x square equal to del u over del y. Okay. This can be written as del square u over del x square equal to 1 over 4 del u over del y. Moving your 4, okay, from the left hand side to the right hand side. Then we start with the first step. In first steps, you know that you need to let u xy equal to a product of x and y. Okay, from here, substitute this del square u, del x square, and del u over del y. So del square u over del x square is basically equal to x double prime y equal to 1 over 4. Del u over del y is x y prime. And then divide both sides with xy. Divide with xy. Okay, so you can cancel out this y and this x. So you left with x double prime over x equal to 1 over 4 y prime divided by y. Okay, it is separable, okay, because you can separate this x and y. Okay, the next steps is you need to rewrite the separated equation as two ordinary differential equation, meaning that from x double prime over x, you let this to be equal to k. And on the other side, you have 1 over 4 y prime over y to be equal to another k, constant. So x double prime equal to kx. And x double prime minus kx basically equal to 0. So you have the first ODE. Then for the second ODE, okay, you have y prime equal to, moving 1 over 4 to the right hand side, you have 4. 4k, and then move your y. So 4ky. And then y prime minus 4ky equal to 0. Now you have two ODEs. Okay. From these two ODEs, you may proceed with the second step. Okay. Okay, in second step, we have the 3 cases. Okay, we start with the case 1. Case 1, when you let k to be positive. So k must be equal to lambda square. When k equal to lambda square, substitute k from x double prime minus, substitute k with lambda square x equal to 0. So find what is the characteristic equation. So this is your second order ODE. So m square minus lambda square equal to 0. So m square is equal to lambda square. So m equal to plus minus lambda. Okay, m1 is equal to lambda, m2 is equal to negative lambda. Okay, so use the table from chapter 2. The general solution for this ODE, second order ODE, is equal to a exponent lambda x plus b exponent negative lambda x. Normally, we use C1. C1 exponent lambda x plus C2 exponent negative lambda x. Okay. Okay. And then do not forget about your y. So y prime minus 4, substitute k with lambda square. Lambda square y equal to 0. Characteristic equation, you have m minus 4 lambda square equal to 0. So basically the root for m is equal to 4 lambda square. You just have one root. So your y is equal to, the general solution for this is c exponent 4 lambda square y, c3. Okay, c1, c2, and then c3. So now you have your x and y. Okay, remember that u is equal to products of x and y. So you can have your solution u. Okay, solution for u x, y is equal to x c1 exponent lambda x plus with c2 exponent negative lambda x multiplied by y c3 exponent 4 lambda square y. Okay, and then you may expand this. Okay, so you have c1 exponent lambda x multiplied by exponent 4 lambda. So you have multiply by c3 exponent 4 lambda square y plus c2 exponent negative lambda x multiplied by c3 exponent 4 lambda square y. And you can have this a1 exponent lambda x plus 4 lambda square y plus b1 exponent negative lambda x plus 4 lambda square y. Okay, with A1 is equal to C1 multiplied by C3 and B1 is equal to C2 multiplied by C3. Since all the C's are constant, okay, so you can write it as A1 and B1 to simplify this. Okay, so we are done with the first case. The second case, okay, case 2, when K is equal to 0. Okay, when K equal to 0, again, we substitute K with 0. So we have 0x equal to 0. So m square minus 0 equal to 0. So basically both m equal to 0. m1 equal to 0. m1 equal to m2 equal to 0. So if m1, m2 equal to 0, your general solution for x, refer to the table. So this is a exponent 0x plus b x exponent 0x. Okay, it is real but repeated. Real and repeated. So you have a plus bx. Because exponent 0 is equal to 0. Sorry. Okay, we can continue from here. It is equal to C4 plus C5x. Okay. And then for y part, y prime minus 4k. K is equal to 0 multiplied by x. Sorry, multiplied by y is equal to 0. So m prime minus 0 equal to 0. So basically m is equal to 0. So for y, it is C6 exponent 0y. So this is C6. Sorry, this is C4. We use C and C5. Okay. And then do not forget to write your UXY. Okay. Copy your x. Your x is C4 plus C5x multiplied by C6. Okay. So you have C4 multiplied by C6 plus C5x multiplied by C6. You can write this as A2 plus B2x. Okay. With A2 equal to C4, constant C4 multiplied by constant C6, and B2 is C5 multiplied by C6. And the last case you need to consider is case 3. When K is negative, K less than 0. Okay, so K equal to negative lambda square. Okay, substitute K x double prime minus negative lambda square x equal to 0. So lambda square plus, x double prime plus lambda square x equal to 0. Characteristic equation, m square plus lambda square equal to 0. So m square equal to, moving your lambda square to the right hand side, it becomes negative lambda square. And then if you apply the square root, your m becomes plus minus lambda I. Imaginary number, complex number. So for complex number, your general solution for x is equal to C7 cos lambda x, because your a, your real part is 0, right? So you have C7 cos lambda x plus C8 sin lambda x. And for the y prime minus 4. We have 4. Minus 4. K is negative lambda square. Y equal to 0. So y prime plus 4 lambda square y equal to 0. Characteristic equation is m plus 4 lambda square equal to 0. Okay, for y, since it is first order, so your m is always 1. Okay, you just have one root. So for this, the root is m equal to -4 lambda square. -4 lambda square. So general solution for y is equal to C9 exponent -4 lambda square y. Okay. Last, you have your uxy. Uxy is equal to C7 cos lambda x plus C8 sin lambda x multiply with C9 exponent -4 lambda square y. Okay, it can be written as A3 exponent -4 lambda square y cos lambda x plus B3 exponent -4 lambda square y sin lambda x, with A3 is equal to C7 multiplied by C9 and B3 is C8 multiplied by C9. Okay, so this is how you solve the separator equation. Okay, the last steps in solving using the method of separation of variables is to find the Fourier series. Okay, Fourier series solution. Okay. PDE always come along with boundary value problem. Therefore, unknown coefficients obtained. Okay, unknown coefficient here is A0, AN or BN can be obtained if you use the Fourier series. If you come across sine 2n minus 1 pi over 2, it is either sine pi over 2, sine 3 pi over 2 or sine 5 pi over 2 ... Okay, it is equal to -1 to the power of n plus 1. Okay, and then second one, if you have cos 2n minus 1 pi divided by 2. Okay, if you have cos pi over 2, cos 3 pi over 2, 5 pi over 2. Okay, so all of this is equal to 0. Okay, now for example 5.7, we will try to solve the PDE using the method of separation variables. We will start with first step and then finish it until the third step. Okay, so basically this is one kind of example that can be asked during the final exam. So find the time dependent solution for uxt when you have this PDE del u over del t equal to 4 del square u over del x square, subject to boundary conditions. So you have boundary condition when u x0, okay, when x0 t equal to 0 and del u over del x equal to 1 and it is equal to 0. Okay, and initial conditions ux0 equal to 2x. So let's start with the first step. Okay, first step. Okay, you have 4 del square u over del x square equal to del u over del t. Then you have del square u over del x square equal to 1 over 4 del u over del t. Okay, you let uxt equal to products of x and t. Okay, so from here you have x double prime t del square u over del x square is equal to x double prime t equal to 1 over 4 x t prime. Then divide both sides with xt. Okay, you have x double prime divided by x equal to 1 over 4 t prime divided by t. So you equal both sides with the constant k. So x double prime over x equal to k and 1 over 4 t prime divided by t equal to k. So from here you have x double prime minus kx equal to 0, first ODE. And then from here you have t prime minus 4kt equal to 0, your second ODE. Okay, and then second steps, okay, consider the first case when k is positive. K is greater than 0. So k is equal to lambda square. Okay, k equal to lambda square, substitute into both ODE. You have x double prime minus lambda square x equal to 0. M square minus lambda square equal to 0. M is equal to plus minus lambda. Okay, so x is equal to C1 exponent positive lambda x plus C2 exponent negative lambda x. Real but distinct. Okay, real and distinct. And then t, for this case t prime 4kt. Okay, substitute with lambda square t equal to 0. M minus 4 lambda square equal to 0. So m is equal to 4 lambda square. Okay. For full step of method of separation variables, okay, we just substitute before we write the uxy and before we continue with the second case of k. Okay, we can substitute boundary condition here. Okay, so boundary condition, we have two boundary condition. For this one, for the first one, you have x0 equal to 0, and the second one is x prime 1. Your x is 1. When x equal to 1, it is equal to 0. Okay, so for this one, u0t means x0. You have your x over here. Okay, substitute x0 equal to 0. So C1 exponent 0 plus C2 exponent 0 is equal to 0. Okay, so you have C1 plus C2 equal to 0, meaning that your C1 equal to negative C2. Okay, for now, we just ignore t. Okay, for the moment. Okay, just focus on the x. Okay, substitute x prime. X prime x. Find what is x prime x from this x. Okay, so differentiate this. You have lambda C1 exponent lambda x minus lambda C2 exponent, this is minus, okay, exponent lambda x. Differentiate this C1 exponent. Okay, we have this x prime, and then substitute x prime boundary condition, second boundary condition, x prime 1 equal to 0. So x prime 1 equal to 0, then lambda 1 C1 exponent x, exponent lambda, since x is equal to 1, minus lambda C2 exponent negative lambda is equal to 0. So we can factorize this. We have lambda C1 exponent lambda minus C2 exponent negative lambda equal to 0. Okay, so from here, you know C1 is equal to C2. Okay, so first you have C1 equal to negative C2, and the second one you have C1 equal to C2. So basically both C1 and C2, you can conclude that C1 and C2 are equal to 0. Okay, since C1 is equal to negative C2 and C1 equal to C2. So both are 0. So we can conclude this, there is no eigenvalues. Since C1 and C2 equal to 0, so we conclude that there is no eigenvalues for this case, for k equal to lambda square. And what you need to do is to omit the case. Thus, we omit the case. Okay. What does it mean? Okay. It means you can ignore this case and proceed with the second case. There is no solution for this case. Okay. For case 2, proceed with case 2. Okay. For case 2, k equal to 0. Okay. For k equal to 0, substitute, you have x double prime minus 0x equal to 0. So m square equal to 0 means that your both m are equal to 0. And then x equal to c3 exponent 0 plus c4x. Repeated, okay? Exponent 0. So you have c3 plus c4x. Okay? You don't have to consider the t part. Okay? Just consider on x first. Okay? So x is equal to c3 plus c4x. Substitute the initial condition. Sorry, boundary condition. The boundary condition, x0 is equal to 0 again. So 0 equal to c3 plus c4 multiplied by 0. So basically c3 is equal to 0. Right? And then find what is x prime. For x prime, you have 0 plus, okay, for this one, you have c4. Okay, so x prime, 1 equal to 0 from the boundary condition. So when you substitute 1 into x, so we don't have any x here, so we have just c4 equal to 0. Again, since c3 and c4 is equal to 0, so you can conclude that there is no eigenvalues. Okay, there is no eigenvalues for second case, where k is equal to 0. Okay, again, we can omit the case. Okay, proceed with the third case. Okay, and look whether we can omit this case also, or we can proceed with the solution. Case 3, k is greater than 0, where k is equal to negative lambda square. X double prime plus lambda square x equal to 0, since k is negative lambda square. Okay, so m square plus lambda square equal to 0. M is equal to plus minus lambda I. So general solution for x is equal to c5 cos lambda x plus c6 sin lambda x. Okay, substitute the boundary condition. When x equal to 0, it is equal to 0. X is equal to 0. Then we have 0 equal to c5 cos 0 plus c6 sin 0. 0 is equal to c5. c6, since sin 0 is 0, so we don't have any c6. So basically c5 is equal to 0. Okay, and then substitute x. Find what is x prime. So we have negative c5, negative lambda c5 sin lambda x plus lambda c6 cos lambda x. Okay, then substitute the boundary condition. X prime 1 equal to 0, then we have negative lambda c5 sin lambda x is equal to 1. Okay, x equal to 1 plus lambda c6 cos lambda equal to 0. Okay, when x prime 1 equal to 0. So substitute the value and then equal to 0. Okay, for this, sin lambda is equal to 0. Okay, so this is 0 plus with lambda cos lambda. Okay, c6 lambda c6 cos lambda equal to 0. Okay, since c5 is equal to 0, so c6 cannot be equal to 0. c6 cannot be equal to 0. Because if C6 equal to 0, so there is no eigenvalues for case 3. Okay, since case 1 and case 2, we just omit case 1 and case 2, so we cannot omit this third case. Okay, so you need to set that C6 must not equal to 0. Okay, C6 cannot be equal to 0. So lambda cos lambda should be equal to 0. Okay, so you have this lambda C6 cos lambda equal to 0. But C6 cannot be equal to 0. So lambda cos lambda should be equal to 0. So when lambda cos lambda equal to 0, cos lambda, moving lambda to the right hand side, you have cos 0. Cos lambda equal to 0. So lambda is equal to pi over 2. So use calculator to check what is the value for lambda to make this cos lambda equal to 0. So basically, if you find cos lambda over 2, it is equal to 0. If you have cos 3 pi over 2, it is equal to 0. Cos 5 pi over 2, until cos n pi over 2. This will make this cos lambda equal to 0. So basically, if we generalize the lambda, we have lambda n equal to 2n minus 1 over 2 pi with n equal to 1, 2, 3, ... Okay, if you refer to this, you know that cos lambda, imagine this is your lambda, cos lambda is equal to 0 when your lambda is 2n minus y over 2 pi. So that's how you generalize the lambda n. Okay. So since lambda n is equal to this 2n minus 1 over 2, substitute into your x. Okay, xn over here. So you may have your xn, you may write xn equal to cn. Okay, since c5 is 0, you have c6 only. So c6, change c6 with cn. And then you have sine lambda n for the general equation, lambda n x. Okay, so you have xn from here, xn, c5 is 0, so you just have c6, and then change this c6 with cn, lambda change with lambda n, and the last, your xn becomes cn sine 2n minus 1 over 2 pi x. Okay, because you substitute this lambda n with this. So this is the general solution for x. You have the general solution for x. Now back to your t. For third case, you cannot omit the third case, so you need to proceed with the t. T prime plus 4, substitute k with lambda square, negative lambda square, so you have equal to 0. So m plus 4m square equal to 0. M is equal to, no, this is m lambda square. Sorry, m lambda square. So m is equal to negative 4 lambda square. General solution for t, time t equal to c7 exponent negative 4 lambda square t. And the general solution for t, t and t is equal to, change this c7 into t. We use t, dn. Okay, let's say it is dn. dn exponent negative 4 lambda square, lambda n square t. Substitute lambda square, lambda n. Previously, lambda n is equal to 2n minus 1 divided by 2 square. This is 2, 2 square is 4, so you can cancel this 4 with this 4. So last answer is dn exponent negative 2n minus 1 square pi square t. Substitute this lambda n with lambda n you get here, which is 2n minus 1 divided by 2 pi. Okay, pi square. Okay, so you have xn and tn now. This is your xn and this is your tn. And then you can write your uxt. unxt, okay, in general form. unxt is equal to xn multiplied by tn. So you have cn sine 2n minus 1 over 2 pi x multiply with dn exponent negative 2n minus 1 square pi square t. Then you can simplify this. Okay, denote this as Pn. Then you have exponent negative 2n minus 1 square pi square t sine 2n minus 1 over 2 pi x. What is Bn? Bn is products of Cn and Dn. Simplify the uxt because we need to substitute the initial condition. Okay. Initial condition ux0 equal to 2x, meaning that when t equal to 0, substitute t equal to 0, you have uxt equal to 2x. Okay, so substitute the initial conditions. You have 2x equal to Bn exponent negative 2n minus 1 square pi square t is 0. Okay, sine 2n minus 1 divided by 2 pi x. So 2x is equal to Bn exponent 0. Everything will be 0 because you multiply with 0 here. So exponent 0 sine 2n minus 1 divided by 2 pi x. Exponent 0 is equal to 1. Okay, now from unxt, when you know that this 2x is equal to Bn sine 2n minus 1 over 2 pi x, so you can have your uxt now without the n. Uxt is equal to, we write in summation, so summation n from 1 to infinity. Okay, then we have Bn sine 2n minus 1 divided by 2 pi x. Uxt is equal to 2x. So 2x equal to n equal to 1 to infinity Bn sine 2n minus 1 over 2 pi x. Now it is the time for you to use your knowledge on solving the Fourier series to find what is Bn. Okay, to find the Bn, it is equal to 2 over L integration from 0 to L fx sine 2n minus 1 over 2 pi x dx. Okay, you remain this sine 2n minus 1 over 2 nx. Okay, over here into this. And then what is your fx? Fx is this 2x. This is your fx. Okay, and then what is the L? Okay, the L is from the equation. L is from your limit of x over here. So x equal to 0 until 1. So L is from, so x is from 0 to 1. So L is equal to 1. Okay, so L equal to 1. You have Bn equal to 2 divided by 1, 0 to 1, fx is 2x, sine 2n minus 1 divided by 2 pi x dx. As usual, you will need to use the tabular method to solve for this integration. For tabular method, differentiation integration 2x sine 2n minus 1 divided by 2 pi x. Okay, differentiate 2, you have differentiate 2x, you have 2. Integrate sine, integrate the whole term, you get negative, okay, cos 2n minus 1 pi over 2x multiply by, differentiate this, 2n minus 1 pi divided by 2. Okay, so you have 2 over 2n minus 1 pi. And then differentiate 0, differentiate 2, you get 0. Integrate again, you have negative sine 2n minus 1 pi over 2x multiply with 4 over 2n minus 1 square pi square. Okay, so Bn is equal to, so you have plus minus plus, plus minus plus. Bn is equal to 2x, you have 4 minus 4x divided by 2n minus 1 pi cos 2n minus 1 pi divided by 2x. Minus minus will be plus. 2 multiplied by 4 is 8. So 8 over 2n minus 1 square pi square. Okay, have sine 2n minus 1 pi divided by 2x. Limit from 0 to 1. So you have 2. Substitute the limit, you have negative 4 2n minus 1 pi cos 2n minus 1 pi divided by 2 plus 8 over 2n minus 1 square pi square sine 2n minus 1 divided by 2 pi. Then lower limit, you have plus 4 over, sorry, this is 0. 0 over 2n minus 1 pi cos 0, since x is equal to 0. Minus with 8 over 2n minus 1 square pi square sine 0. Okay. Refer to the note here. Substitute the sine 2n minus 1 pi and cos 2n minus 1 pi over 2. For cos, for this one, you have 0. This is equal to 0. Sine is equal to negative 1 to the power of n plus 1. Okay, and this is, everything becomes 0 since you have 0 here. And for sine 0 is equal to 0. We have Bn equal to 2. Okay, 8 over 2n minus 1 square pi square. Sine is equal to negative 1 to the power of n plus 1. And the rest are 0. So this is our answer for Bn. 16 over 2n minus 1 square pi square negative 1 to the power of n plus 1. And do not forget to write your last answer. Uxt is equal to, substitute uxt into here. Sorry, substitute Bn into this uxt. Okay, so uxt is equal to summation n from 1 to infinity, and then Bn. Bn is 16 negative 1 to the power of n plus 1 over 2n minus 1 square pi square. Sorry, you don't, it's not this uxt. Sorry, class. It's this uxt. You need to substitute into this uxt. Okay, This is the general solution. Okay, substitute into here. Okay, you will have the exponent. Okay, so exponent negative 2n minus 1 square pi square t sine 2n minus 1 over 2 pi x. This is the last answer. Okay, so there are many steps in solving method of separation using method of separation of variables. Okay, from the first step, you need to spread the variables. Second step, you need to consider the 3 cases and then to omit the first 2 cases. Since normally the first 2 cases will give you no eigenvalues, so you just need to omit these 2 cases. Okay, and then the case 3. In case 3, okay, you need to find what is x and then x prime x to substitute the boundary condition, and then you will find what is your xn, and then find what is tn. You have your u and xt. Okay, and from u xt you can find what is bn. Once you get your bn, you will have the last answer, u xt. So it involves a lot of effort in solving this chapter 5 problem. So that's all for this week video. In next week video, we will see the 2 examples of PDEs, which are heat equation and wave equation. We will try to solve these 2 PDE using method of separations of variables. Thank you.